Okay, we're starting on the oblique plane section of the worksheets. This is sheet number 1 and it's on page 101 of the worksheets. Before we get to the worksheets, we're going to go through just two little examples. So we have a line in elevation and plan here. Line is 1, 2 in elevation, 1, 2 in plan. To see the true length of a line, I have to look in at 90 degrees to it. So in my elevation, when I'm looking at an elevation, I need to stand out in front of the line and I'm looking directly in here. So when I'm down in the plan, I look in at the line and from that we project our elevation. My line of sight is at 90 degrees. So because that line 1, 2 is parallel to the XY line in plan, I'm going to see a true length of it when I go to the elevation. So I project up and I see the true length. This is the true length of that line. And it's also the true inclination, the true angle between the line and the horizontal plane, which is here. So I can measure that angle. When we come to the second line, this one here, this line is horizontal in the elevation. So this line is actually horizontal. For me to project a plan view, I need to look down on top of this line, directly down on top of this line. So I'll be looking in here. Again, my line of sight is at 90 degrees to the line. So I look down on top of the line in elevation, project down, and I get my plan. This plan shows the true length of the line. It also shows the true inclination between the line and the vertical plane. So it's different than the other question. It's showing the real angle between the line and the vertical plane. So here's my vertical plane when I look at the plan. So they're two different things. The most common version is we project from a plan, we draw an elevation to see the true length. So this is the most common setup we'll have, where we look at 90 degrees to a line to draw an elevation. And again, because this line here is parallel to the XY line, I'm automatically looking in my normal plan. So when I project my normal elevation, I see the true length. When I get to these questions, they're different. This line now is neither horizontal in elevation and it's not parallel to the XY line in plan. So neither of these views are the true length. I need to find the true length. The principle is the same. I'm going to use my plan and I'm going to look in at 90 degrees to the line. So I'm going to come in here and I'm going to set up a 90 degree line of sight looking in at the line. To do that is fairly straightforward. I come off at 90 degrees to my line, project out 90 degrees, and I'm projecting an auxiliary elevation. And project out. I'll step out and put in an XY line. Anywhere there at all, I'll put in my XY line, X1, Y1. So I projected out an auxiliary elevation. It's an elevation I'm drawing, so I'm going to take my measurements from elevation. Height of point 1 is here. I measure that height from the XY line. There's 1. Height of 2. And I measure the height from the XY line. Height of 2. Join 1 to 2. That is the true length of that line, because I'm now looking in at 90 degrees to the line. So I've moved. I'm looking in 90 degrees to the line. This gives me the true length. It also gives me the true inclination. So in other words, this angle here is the true inclination. So that's the real angle between the line and the horizontal plane. So that's the true angle and true inclination.